Over the last 100 years, we've been able to mitigate the impacts of many natural disasters like droughts and floods, but earthquakes stick out like a sore thumb in this trend because they've consistently taken the largest toll on human life across all natural disasters, and it's showing no sign of decreasing because of continuous urbanization. Now, because we cannot predict when and where the next earthquake will happen, our best way to combat their impact is by providing emergency aid. But if an earthquake were to happen here right now, it's not the earthquake that would kill us, it's the damage that's caused to this building that would kill us. So for disaster response, what we need is a map that tells us where the buildings have been damaged and how severe the damage is. And the map needs to fulfill two basic requirements. It needs to be big, because earthquakes can span entire countries, like happened in Myanmar last year. And it needs to be produced rapidly, because the first 1 or 2 days after an earthquake are essential to ensure effective disaster response. We can fulfill requirement number 1 by using satellite data. Like at the moment, we use quite often optical satellite data for our damage assessment. But the problem with this optical satellite data, which by the way looks a bit like the satellite images you see on your Google Maps view, the problem is that when it's a cloudy day, all they can see is a bunch of clouds and they don't actually see anything on the surface. So to get a cloud-free image after the earthquake can sometimes take days or even weeks, which means we're not exactly providing a rapid map at that point. So it's a fundamental limitation of using optical satellite data for this purpose, which is why instead, in my work, I've been looking at using radar satellite data for damage assessment. These radar satellites work a little bit like ultrasounding we use for pregnancies, where the idea is that we send out a signal and it comes echoing back to us, and that's what forms our image. But instead of tracking human health or pregnancy, what we track is urban health. So I built an automated model that essentially uses images from before the earthquake to build up statistically the image of what a healthy urban area looks like, and then tests whether we significantly deviate from that when we see an image after the earthquake. Now, I've tested this on a bunch of past earthquake events and found out actually that this can work just as well as people manually mapping the damage in optical satellite images. And this is a crazy fact because if you look behind me, just like how ultrasounding can look through your skin to map out what's underneath, these radar satellites, they can penetrate right through the clouds and map regardless of weather conditions. And so we're able to identify both a big map and provide it rapidly. And so my work illustrates that if we start building these damage assessment models, currently mostly on optical satellite data, we should actually not be ignoring the radar satellite data because it can provide a lot of help for us. So if we want to provide better damage assessment, we should be harnessing the power of radar satellites instead to fight back against the devastating impact of earthquakes. Thank you.